This particular question is based on force of gravity, which is inversely proportional to the square of the distance. So the formula can be written as F1 upon F2 is equal to d2 squared upon d1 squared. Now here you can see that this is 10 Newton, so we can have F1 as 10 Newton, and the distance between them is reduced to half. So therefore d2 is half of d1. So we can say d2 upon d1 is equal to 1 by 2. So therefore this, which is d2 upon d1 squared. Okay, so I will write f1 as 10, this is f2, and this is 1 by 2 squared. This is f2 and this is 4. So f2 is 10 into 4. F2 will be 40 Newton. So that means when two bodies are attracting each other with a force of 10 Newton, and when their distance is made into half, then this force will become 4 times, that is 40 Newton. So this particular question is now based on the fact that if mass is equal to a kilogram, then the weight is a kilogram force, or it is a times g Newton. So here we have 5 kgs, so m is equal to 5 kgs. M is equal to 5 kgs, so they are asking for weight. So the weight will be 5 kgf. So that weight is given as 5 into 9.8, which will be equal to 49 Newton. So over here our assumption is that we took g value as 9.8 meter per second squared. You can also get the answer as 5 into 10, that will be 50 Newton. So in that case your assumption will be g is equal to 10 meter per second squared. So your answer is either 49 if you take this as 9.8, or it will be 50 if you take this as 10 meter per second squared. This again is a pretty straightforward question. So here we have uh, mass as 10 kilogram, and if you want to write the weight, that will be 10 kilogram force. And now if you need it in Newton, you know that it is 10 times g. The value of g is provided to us, that is 9.8. So the answer is 98 newtons. So this is our first answer in terms of kgf, and this is the second answer in terms of Newton. Again a similar question. So this time it is given that the mass is 5 kilograms. They have given the value of g as 9.8 meter per second squared. They are asking for the magnitude of the force. So F is equal to mg, 5 multiplied by 9.8, so that is 49 Newton, and the direction. So this is a force with which the earth pulls any body toward itself. So therefore the direction will be vertically downward towards the center of Earth. So if you consider this to be Earth and this is any body, so the force is directed toward the center. So that's the weight. This question can be called a similar question, but it is little opposite to what we have done so far. This time the weight of the body is provided. So the weight is given to be 2 newtons. They have given us the value of g as 10 meter per second squared, and they ask us to calculate the mass. So we know that weight is mass into gravity, acceleration due to gravity. So this is m into 10. So m will be 2 by 10. So mass will be 0.2 kilograms. So moving on to the next question, here we have the weight of a body on Earth as 9.8 newtons. So if I call this as weight on Earth as 98 newton, and the acceleration due to gravity of Earth is 9.8 meter per second square. Now using this information, if I calculate the mass of the body, so here I get 98 into mass into 9.8, I will get the mass as 10 kilograms. Now they are asking us that what will be the mass on the moon. So we know that mass remains unchanged. So if you go from one place to another, mass does not change. Since the acceleration due to gravity changes, the weight will change. So therefore answer of the first question is mass will be 10 kilograms. Now they are asking for the weight on the moon. So weight on the moon will be mass times acceleration due to gravity of the moon. Now this is given to be 1.6. So therefore this is 16 Newton is the mass on the moon. Moving on to the next question over here. The weight on Earth is given as 600 Newton and the weight on moon is asked. Now we know that acceleration due to gravity on Earth and acceleration due to gravity on the moon, if you compare it, so acceleration due to gravity on the moon is 1/6 of that of Earth. So therefore weight on the moon will be 1/6 of that on the Earth. So therefore we get weight on the moon will be 1/6 of the weight on the Earth. So that is 600 over here. So weight on the moon is 100 Newton. So mass doesn't change, but the weight changes. So in this question now we have the mass as 10.5 kilogram, and they are asking us to calculate the force and the weight which acts on the mass. So ideally, like, the force and the weight means the same. So this is Earth and this is a body. In this case this is like 10.5 kilograms. Now this body is pulled towards the Earth with a force. Now this force is the weight of the body, and that force is given by m into g, acceleration due to gravity. So the force equal to the weight is mass into acceleration due to gravity. So this is 10.5 into 10 is given as 10, so that will be 105 Newton. So answer for force and weight both is 105 Newton. Okay, so here the question says that you're holding a mass of 5 kg in your hand. Now let's assume only one hand at a time. So over here this is 5 kg bag, and therefore the force that the muscle need to apply should also be equivalent to the force with which these bags are pulled down, and that force or the weight of the bag is m into g, so that is 5 into 9.8, that will be 49 Newton. So these bags are pulled down by 5 kgf, so that will be 49 Newton. So to hold them, the girl has to apply a force of 49 Newton upwards. So therefore the force required by the muscles is 49 Newton. They are asking for the assumption. This is the assumption. So the assumption is G is 9.8 meter per second squared. If we take G as 10 meter per second square as our assumption, then that force will be 5 into 10, that will be 50 Newton. Okay, so here is another question. So here we have a ground, and this is a ball that is thrown up. So let this velocity be u with which it is thrown up. This ball goes to a height where its velocity will become 0. Let's call this as v1, and then again it comes down, and this time the velocity will be v2. We need to take into account one thing, that the time taken to go up is equal to time taken to come down. Also, since these 2 points are at the same level, these two velocities will be equal, but the signs will be opposite because they are directed opposite. So if I take this u as a negative value, v2 will be a positive value. And we know that acceleration due to gravity is always acting towards the ground. So taking down the information what they have, the height that they have given is 20 meters, and acceleration due to gravity is 10 meter per second square. Now how do we proceed? The first thing that we need is initial velocity. So I'm using the condition that when the ball reaches the topmost point, its velocity will be 0. So the formula is v is equal to u plus at, and then what we have is 0 is equal to u plus 10 into t. Now we don't have both these values. We don't have u, we don't have t. So we can use an alternate formula which does not use t. That is v square is equal to u square plus 2as. So here we have 0. This is u square. This is 2 into 10 into 20. As you can see that this is 20. So I get u square as minus 400. Since this is a square, I am taking only the magnitude. Okay, I am taking only the magnitude, not the sign. So this is 400, and we get u as 20 meter per second. So this is the initial velocity. So this value we got it as 20. So therefore v2 will also be 20. So therefore we get v2 is 20 meter per second. As mentioned before, the signs will be opposite. That if I call this as negative 20, this will be positive 20. So I got my initial velocity, I got my final velocity. Now we need to calculate the time. So here I can use this value. So 0 is equal to 20 plus 10 into t. So here I have taken this as negative, so I can call this as negative, and therefore t will be 20 by 10, t will be 2 seconds. But what is this? This is taking into account the final velocity to be 0, that is over here. That means this 2 seconds that I have got is time to go up. So therefore time to go down will also be 2, and therefore the total time will be time to go up plus time to go down, and that will be 2 plus 2, and that will be 4 seconds. So this is your final answer. Okay, coming to the last question of the series. So here there is a ball is released. So when release u is equal to 0 from a height, and it reaches on ground in 3 seconds, so time is equal to 3 seconds, and g value is given as 9.8 meter per second squared. So how is this situation? So here there is a height, so that is h. A ball is released, so that means u is equal to 0. The ball comes down under the gravity, and then it will reach ground, so that will be v. So we don't know this, and we don't know the height. So let's calculate the height. So we have s is equal to ut plus half at squared. So s, which is displacement, which is this height, this is 0 into 3 seconds plus half into 9.8 into 3 into 3. So this will be 4.9 into 9, and that height will be given. The height will be 44.1 meters. So this is the first answer. Now they are asking us to find this velocity. So we have v is equal to u plus at. This is 0 plus 9.8 into 3. So that velocity will be equal to 29.4 meter per second. So this is the velocity with which the ball will strike the ground. That's the end of the series. See you next time. Thank you.